I am so close to being ready. I almost got ready without going live. Interesting. Okay, whilst you're waiting for me, feel free to grab a tape measure, which we'll need today, she says, looking for hers. Yep, got it. Calculator, a pencil, and a piece of paper, or something to write with and something to write on, essentially. Also, have a think about this. What do you notice about this picture? And what else? What else can you do? You can definitely do liking and subscribing. That will definitely help people see this. Yeah, I mean, if you've done all of that, just sit and chill for a couple of minutes, I suppose. Yeah, go for it. Just light myself a little Palo Santo incense stick to enjoy. Also, we do some maths. Maths. Yeah. I know you're all sharing it with me. Definitely, 100% here. Right, almost there. Be back in a sec. Just need to grab a glass of water. Good morning, Maths Mom! How are you doing, guys? It's Friday. I love a Friday. I do love Fridays. I don't know, they're just my favourite day. Absolutely, they have been for years. I just love Fridays so much. Hello, I'm Ruth. This is Joyful Maths with Ruth. If you are home educating and you are looking for a free all ages math lesson about topics that you vote for and I find the maths in, you are absolutely in the right place. Well done, you. Today we are continuing our journey through maths in animals, looking at animals with shells. And I showed you a picture of a shell. Now, if you, like my family, have at least one member that is a bit obsessed with something called Minecraft, you possibly know what animal this shell is from, because by the end of the year there is a Nautilus update coming out. Have you heard about it? Have you heard about it 20 times this morning? Because I have heard about it lots, and therefore I created a lesson all to do with Nautiluses. And this is the inside of a Nautilus shell. Also, Google tells me. Yeah. Was it from Google? Was it Canva? I can't remember. Yeah, I think it is anyway. Something to think about. What did you notice here? What did you notice? Oh, you can't leave comments on this one, on my YouTube lesson. But I did this lesson on... Did I just say but funny there? But. I don't know if I did. Maybe that's just me. I did this lesson on Tuesday on Facebook, so I could tell you what these people said on Facebook about it. Lots of people said bits that are smooth, bits that are bumpy. Absolutely. You can see the inside here, there's quite bumpy bits. This bit would be nice and smooth, and the outside of this shell would be quite smooth too. Lots of people, somebody clearly just like wanted to be my best friend ever, and they officially are now, because they said fractals. They said, and I was like, yes, I didn't even think of this, but absolutely. If you could spot fractals, if you've got my fractals like magazine pack, you will have, like, you'll know about fractals, won't you? You'll know all about fractals. But like, yeah, Fractals are when you see the same pattern, same shape, repeated multiple times, but changing in size. So we've got this shape here, you can see, and you can see it repeating multiple times, but it's getting, well, I suppose it got bigger actually, didn't it? The little animal started off teeny tiny in here, and as it got bigger, it had to create bigger and bigger sections of its shell to grow into. This would be the bit where the Nautilus lives. Now it is a big Nautilus, so it needs a big space. Absolutely. And lots of other things. So these are other, this is a living Nautilus. So you can see this is the bit where this is the outside of the shell, and this is the animal coming out of it. I don't know if that's the eye. It looks like an eye, doesn't it? I didn't actually check. And this is just like, say we've sliced it open, the shell, to see inside of it. These are some things that I saw getting bigger. The chambers are getting bigger. It's been cut in half. We can see the spiral shape, some chambers, and one person said this on Facebook, and I was like, are they going to say it? Did anyone say Fibonacci? Did anyone say Fibonacci? Because that's what lots of people say. Mathematicians, non-mathematicians, lots of people like to say. In nature, in how many times can I say in? in. It's obviously in it a lot. In the universe, if you look at the skies, if you look at solar systems, if you look at plants and animals, big things, small things, lots of people say you can see something called the golden ratio, which we're going to explore today, which comes from a Fibonacci sequence or creates a Fibonacci spiral. All of these are words that maybe some of you are like, yes, I know about these. Some of you might be like, what? Don't worry, I'm going to show you. What I mean. So here is a Fibonacci spiral placed over the top of our Nautilus shell there. Can you see? This is the Fibonacci spiral. It's if I zoom right in, if I take you really, really close up, can you see? It's made up of lots of squares initially. So there's little squares, and they're getting bigger and bigger and bigger and bigger, bigger and bigger and bigger. And then using the squares, we've created a spiral. It's going from one corner to the other. It's essentially quarter of a circle each time. Quarter of a circle. It creates this spiral that's getting bigger and bigger and bigger. But is it a Fibonacci spiral that we see? Is that what we're seeing? Is it definitely a Fibonacci spiral? Well, I guess we need to know a little bit about Fibonacci to be able to answer that. Before we talk about Fibonacci, however, I've got a couple of tasks for you. So today your tasks are going to be measuring and recording tasks. And we're gonna see if we can find out how golden your ratios are. If you fit in with Fibonacci. So we're going to start off. The first measurement is going to be from your belly button to your feet on the floor. I'll show you. So I accidentally, on purpose, wore this on Tuesday. Let me just move that so that I could show you my belly button without showing you my belly button. It worked so well. I'm doing it again. Oh no, you can't see my feet. You need to be able to see my feet. Let me just tilt you so you can see my feet as well. Right. So, now you're not going to see my belly button. Gosh, this is complicated. There we go. Here we go. Right, look, I wear this. I like open water swimming, and I put this on afterwards to warm up my belly region. It's a nice little look. It's a little fox. It's got a nice little tail. That's not important though. What we're looking for is the fox's nose, and I'm going to tell you that's right on top of my belly button, so I don't have to show you my belly button. And we're going to get your tape measure. You want to get your tape measure. Mine won't extend down. It's just not doing it for me. So I'm going to have to do mine upside down. I'm going to extend it down to my feet on the floor and measure the height from the floor up to my belly button. So I'm just going to put my finger there. I'm hoping it's the same measurement as on Tuesday. Maybe I've grown. Who knows? Let's see. I'm going to do mine in centimetres. I'm going to recommend you also measure in centimetres. If you choose not to, if you choose to use, say, inches, do all your measurements in inches, please. Otherwise, this won't work. You have to have them all in the same, scale, okay? Right, can you see here? Mine is on 96 there. Oh, it's not. Yeah, 96 centimetres. So once you've done that measurement, the important thing to do now is make a note of it somewhere. Make a note. Now, we need to know that this is your first measurement. A couple of different ways you could do this. We could label it as measurement 1, which is what I'm going to do, or we can do them in order going down in the list. I'll do both. So my first measurement is 96 centimeters. That's all you need to write. That's it. That's it. Measure right, or get someone to write it for you. You know, that's what people are here to help you with. Whilst you do that, I'm going to talk to you a little bit about Fibonacci. Fibonacci was a little Italian lad. He was born in 1183 AD. Doesn't sound very year-like, does it? But that's the only way I know how to say it. 1183 AD. So we're talking like, what, 900-ish years ago? Yeah, around 900 years ago. And he was the son of a merchant, which is a guy that just went around selling stuff, basically. Fibonacci, because he was born in Italy, and at the time the Romans were conquering here, there, and everywhere, but they ruled, and all their numbers were in Roman numerals. You've probably seen them before. They're like so some of them are dashes like this thing. You might see them with little lines above or below. You see V's for 5, I believe it is, X's for 10. Sometimes you see them on clocks and things like that. Okay, so Fibonacci learned to do all his calculations, all his number work in Roman numerals. It doesn't lend itself nicely to doing maths, though. Roman numerals are quite complicated to do calculations with, and often people use abacuses because of this. So, like the Roman numeral system, you had to add on different characters depending on what you wanted to the number. So if I wanted to write, say, 928, I would need symbols representing 8, which actually is made up of 5s and 1s. I would need symbols representing 20, so 2 lots of 10. So I'd need X written twice for that. And I would need symbols representing 9, which actually I need 900, sorry. So I would need 900s, and I can't even remember. I think that's a C. And there might even be one that represents 500. But you can see we end up with this really, really long number. And the bigger the number gets, the more symbols I need to represent it. Not useful, really, really challenging to do calculations with. But Fibonacci was lucky because his dad was a merchant. He traveled around a lot, and he got taken to North Africa, where he learned the Hindu Arabic system, which is essentially what we use today, which is place value. So for us, 928, we don't need different digits. We can use the digits 0, 1, 2, 3, 4, 5, 6, 7, 8 in any place, and it tells us how much it's worth. And we just know that 8 means 8 lots of 1. We know that 2 actually means 2 lots of 10. And we know that 9 actually means 9 lots of 100. Okay, so just this is the version we use today. Fibonacci brought it back from North Africa to Europe, started using it and showing other people it, and it stuck because it's much better to do calculations with. Okay, we're going to talk a bit more about that in a second, and how he came on to breeding rabbits. Yeah, I know. It feels like a leap, doesn't it? But it's it's useful. Before that, we need to do another measurement. Again, we need our belly button. This time we're going head to belly button. So I'm going to stand up and make sure you can see my head and my belly button. Well, where my belly button is represented by a fox nose. Is it in the right place? Yes, it is. Did I just poke my finger in my belly button live? Awesome. Can't think of a better thing to have done today. Right, so there we go. I think that is my head to my belly button. This is our second measurement. We want to go from the top of our head to our belly button, or the other way up is fine too. So for me, that gives 63. Can you see that? 63 centimeters. Again, if you measured in something other than centimeters, stick with that. Same measurement again, please. And I want you to record this again. We're going to need this. All right. So let's get rid of my Roman numerals. Second one, we're going to put it, you can either label it number 2 or put it underneath so you know it's the second one. 63 centimeters. Now, we're going to do a calculation. This, are we going to, should we do the calculation? No. No, we'll do the calculation. I'll give you a second to do that. I'll talk to you about rabbits. I know you can't wait to. So the story goes that Fibonacci was posed some problems by a girl whilst he was over in Africa, and he couldn't solve them. And one of the problems was to do with breeding rabbits. He may have even had some rabbits to breed. And he started looking into how many rabbits he would have each month as the rabbits bred and grew in capacity, in amount, assuming that these rabbits all live forever. We're just going to make the assumption they live forever because sometimes we just do that in maths. Yeah. Okay, so he's going to start off with one pair of rabbits. Now, a little bit confusing here. We're talking about pairs, not the number of rabbits. We're talking about the pairs. So this looks like two, but it's not. This is one pair of rabbits. You might be able to see, I'm hoping you can see, that these rabbits are grey in colour. This causes me issues. Can you see that they are grey in colour? Let's see. Let's make sure we can see. So they're grey in colour because these are baby rabbits. They are not mature yet, so they can't have their own babies. So this is January. We've got one pair of baby rabbits. In February, we've still got one pair of rabbits, but they are now adult rabbits. So I've represented those in black. So these are now adult rabbits. The next month, we've got one pair of adult rabbits. They are now mature, so they can have their own baby rabbits. So then when it comes to March, we actually end up with more rabbits because these adult rabbits are still alive. We're assuming they live forever, but they've also had their own baby rabbits. So we've got another pair. So we started off with one pair of rabbits. The next month, we still had one pair of rabbits. The next month, we've got two pairs of rabbits. What happens in the next month, I hear you ask? Well, don't worry, I've got that answer for you. The adult rabbits remained adult rabbits and also had another pair of baby rabbits. The baby rabbits became adult rabbits. So we started with one pair of rabbits. The next month, we still had one pair of rabbits. The next month, we had two pairs of rabbits. And in the next month, we had three pairs of rabbits. Have a little think. What do you think is going to happen in the 5th month of May? The month of May. How many pairs of rabbits are we going to have? Have a little think about that. How many pairs of rabbits will we have in the next month? It's hard to know how much thinking time to give it. If you've got the workbook, you can do little drawings of this. You can do drawings even if you don't have the workbook. You never need the workbook to engage in these sessions, but you know, some people like to have them. So you can just grab those off my website at any point. So let's have a look what happens in May then. So these are adult rabbits. This adult rabbits, they are going to remain adult rabbits, but they are also going to have another pair of baby rabbits. So they've remained adult rabbits, but they've had another pair of baby rabbits. These adult rabbits remain adult rabbits, but they've also had a pair of baby rabbits. And our baby rabbits turned into adult rabbits. They couldn't have babies yet. So we've now got 1, 2, 3, 4, 5 pairs of rabbits. And this is the start of a very special sequence called the Fibonacci sequence. It starts 1, 1, 2, 3, 5. And keeps going from there. We're going to talk a little bit more about that in a second. But now I need you to grab a calculator. Hopefully you've got one. You can do this without, but it's like, we don't need to. I'm going to use a calculator. What we're going to do, we're going to take your first measurement, and we're going to divide it by your second measurement. So my first measurement was 96. I'm going to divide it by 63. And I'm going to get the answer on my calculator and write that down to, it's going to come up with a lot of numbers for most people, not everyone. For most people, it'll come up with a lot of numbers. I'm just going to write some of them down, okay? So let's, how can I do this calculation so you can see? Here we go.
So 90, I need to turn it on, don't I? There we go. Let's start with turning it on. 96 divided by 63. Now, if your calculator's like mine, it'll put it as a fraction. I need to turn that into a decimal. I'm going to press this S to D button. That turns it into a decimal. I get a really, oh, I've got different to last time. I've got more golden. How amazing. Okay, so I've got 1.5238095, and it goes on and on and on. I'm just going to take the first sort of to 3 decimal places. 1.52, well, 1.523, but that 8 would round it up. So I'm going to write down 1.524. 1.524. Now, we write that answer down, 1.524. You'll have a different number to me. Don't worry too much about the rounding bit. Just write down as much as you number as you want to, okay? That number is important. So we're going to make it look important. We're going to I'm going to put a big box around it. You might want to put a few stars around it. If you've got a glittery pen, feel free to glitter it up. This number's important. We keep this number. Do not lose that number. It is important. Have you got that? Important number. Highlight it. So we took your first measurement. In your second measurement, you did the first measurement divided by the second measurement. Write down your very important number. Okay. Back to my rabbits. I promise it'll all come together. It seems like it's chaotic at the moment. I've done this gene, I've taken it from this direction, and it'll all come together. I promise. I promise. So let's have a look at these numbers. We've got 1, 1, 2, 3, 5. These were our numbers of pairs of rabbits. And what Fibonacci noticed, he noticed 2 really key things. One was that we could continue this sequence without breeding rabbits. We could take these 2 numbers, the first 2 numbers, 1 and 1. If we add them together, we get the next number, 2. Then if we look at the next pair of numbers, 1 and 2, and we add those together, and we get 3. Then we look at the next pair of numbers, 2 and 3. We add those together, and we get 5. And Fibonacci noticed this was a pattern that we could continue. So my next question to you is, what are the next 3 numbers in Fibonacci's sequence? What are the next 3 numbers in Fibonacci's sequence? So I'm going to, some people will be away with that now, and some people will be like, what? Tell me that again, Ruth. That was a lot of words and a lot of information all in one go. That's fine. Let's do that. Let's do that. So Fibonacci's sequence started 1, 1. So there was 1 pair of rabbits that were baby rabbits. The next month, there was still 1 pair of rabbits. So to get to the next number, Fibonacci said, right, take these 2 and add them together. And that will give us our next number, 2. Then for the next month, we can ignore the first month. We just need these 2 here. The last 2 numbers in the sequence. If we add those together, 1 and 2, we will get our next number in our sequence, which is 3. Then we need to take the next 2 numbers, the 2 and the 3, add those together. That's going to give us 5. I'm asking you, what are the next 3 numbers in this sequence after 5? So for the next one, you've probably done 3 add 5. 3 add 5. And you get 8. What would you do to get the next one and the one after that? I'll give you a second to think about that. So did you do 5 plus 8? 5 plus 8, which gives us 13. And then 8 plus 13, which gives us 21. And this is going to keep going. And you probably started to spot that we're missing some numbers. We started off just missing 4 here, didn't we? But then we missed 6 and 7. Then we missed 9, 10, 11, and 12. So the gaps are getting bigger and bigger. It's growing faster and faster, just like our Nautilus shell. Started off growing little bit, but as it grew, it actually grew faster. So the next 3 numbers were 8, 13, and 12, just like this. And this links to this Fibonacci spiral, which looked a lot like our Nautilus shell. And you can draw this yourself, actually, if you want to. You start off by a little square. I might do a video of it sometime because I quite like doing this. Little square that is a 1 by 1 square, then another 1 by 1 square. And then we keep going around and around. You go to the right, up, to the left, down, to the right, up, to the left, down. We've got a 1 by 1 square, 1 by 1 square, then a 2 by 2 square, then a 3 by 3, then a 5 by 5, an 8 by 8, and so on and so on. And you can see this is the numbers in our pattern. 1, 1, 2, 3, 5, 8, 13, 21. The next number will be 34 because we add the 13 and the 21 together. And we get the spiral shape by drawing quarter circles in these. So joining 2 of the corners up, we get these quarter circles. So you could see, maybe imagine that we could keep going around. It would make a massive circle for each one, but we only need a little bit of it. And that's the Fibonacci spiral. Okay, I've got 2 more measurements for you to do. 2 more measurements. This one is a little bit easier. We don't have to stand up for this one. We're measuring the distance from your wrist to your elbow. Wrist to elbow this time. So put that on my wrist. Length of my wrist to my elbow. Oh, it's hard to see elbow. It's like, have you ever tried to lick your elbow? I'm not going to do that on camera. I have some nous about me today. Not all the time. Okay, so mine works out about 24 centimeters. That's my 3rd measurement. So I'm going to write it underneath my very important number. Okay, I'm going to write it underneath my very important number. My 3rd measurement was 24 centimeters. It's not a very important one. We don't need to highlight that one, just the very important golden number. Okay, well, we'll come back to whether it is golden or not later on, actually. Okay, the other thing Fibonacci noticed about this sequence is something special here. There was another relationship between these numbers. When he took the pairs of numbers that we added together and did a division, he found a pattern. He did 1 divided by 1. Then he did 2 divided by 1. So the larger one divided by the smaller one. Then he did 3 divided by 1. Then 3 divided by 2. Then he did 5 divided by 3, 8 divided by 5, and so on. And he kept going. And as he went along the sequence, it got closer and closer and closer to a really special number. And this is that number just to 3 decimal places. So 3 numbers after this decimal point, 1.618. Also known as phi. So this is a Greek symbol for called phi. Represents this, which is known as the golden ratio. Oh, look at it all sparkling golden. And this sequence tends towards that ratio, taking the pairs. It doesn't start off as it. If you do 1 divided by 1, you get 1. If you do 2 divided by 1, you get 2. But 3 divided by 2 gives you 1.5, and so on. It gets closer and closer and closer. And you can get more and more accurate as you go along, closer to that golden ratio. So that number has come from it's looking at the what you would have to multiply the smaller number by to get the bigger number, essentially. But we get it by doing that division. We're dividing the bigger number by the smaller number. And we're going to come to how that links to you very, very soon. Okay, last measurements. Okay, we're going to measure the length of your hand from the wrist up to your longest finger, which is probably your middle finger. For most people, it's the middle finger. Again, in centimeters. So mine is 16. Can you see that? 16 centimeters. It's not. There we go. 16 centimeters. That's my 4th measurement. So I'm going to write it down underneath my 3rd measurement. 16 centimeters. And again, we're going to find a really important number by doing a division. We're going to do our 3rd number divided by our 4th number. So 24 for me divided by 16. Your numbers will be different unless we are just so in tune and in sync that we've got the same measurements as each other. That could be quite something, couldn't it? So we pop this into our calculator, and that's going to give us our 2nd really important number. Okay, 24 divided by 16. You put your numbers in. Don't put mine in. You put your numbers in. Okay, you want your super important number. Okay, so I'm going to do 24 divided by, what was it again? 16. Can't remember anything. What's that going to give me? Oh, 2/3. Press my S to D button, turn it into a decimal. That gives me exactly 1.5. Exactly 1.5 this time. So I don't have to round that one. I'm just going to write it as 1.5. Very close to my other one. Very close. So that one's 1.5. Super important number. We're going to highlight that again. Put some big stars around it. Woo! Celebrate that number. So I've got two numbers on here. And these are two ratios about body parts for me. So this is the ratio of the length of the bottom part of my body to the length of the top part of my body. And this is the ratio of my hand length to, well, my arm length to my hand length. And I've got those by dividing the larger measurement by the smaller measurement. And both of mine are relatively close to each other. 1.524. So 1.5, we could round that to, and 1.5 exactly. What are yours? Have a little look at yours now. Have a little look at your super important numbers. And what I want you to do is decide, essentially, how golden are you? How golden are you? This is the golden ratio, 1.618. We could round that to 1.6 if we wanted to. Fine. How close are you to the golden ratio? Well, I can only assume that my measurements have improved since Tuesday when I was getting 1.4 because I've got more golden since Tuesday. On Tuesday, both of my ratios were around 1.4 and now they're 1.5, which is closer, but it's still not 1.6. It's not bad, is it? If you're getting 1.6, your ratios are pretty golden, eh? Your ratios, and that's one of the things that we talk about frequently, is there's various different measurements around the body, and you'll see it in art as well, that certain measurements you can predict almost, because although maybe my ratio isn't perfectly golden, if you took a huge representation, so many people, and did those measurements and took an average, then it's very likely that that average would give us the golden ratio. So that really helps artists when they're proportioning body parts and drawing them. It's really cool. So back to the Fibonacci spiral. Back to the Fibonacci spiral is our Nautilus. If we look at our Nautilus here, I'll look at our Nautilus cell. Is it the same as the Fibonacci spiral? The answer is no. Essentially, it's not exactly. It's very similar. Another word for this type of spiral is called a logarithmic spiral. It's increasing by a proportion as we go around. But the proportion for the Fibonacci spiral is this golden ratio, 1.618, whereas this is a different ratio. Our Nautilus will have a different ratio. So it's a different amount that we're increasing by, we're multiplying by each time. So how close? Yeah, well, I asked that already, didn't I? How golden are your ratios? I have put a little Facebook post up if you want to say hi. There's a little post where you can say hi on Facebook if you've got it. If you want to tell me how golden your ratios are in that too, I will be very, very interested. Very interested indeed. So far, I think most people that were commenting on Tuesday, it was around 1.4 to 1.5, which is interesting. With that in mind, I'm expecting some people to be over 1.7, like close to 1.7 or 1.8 to balance it out. Okay, we are going to end today on a little quiz. How many questions have I got? I've got 3 questions. It's Nina versus Nate. Nina and Nate, they are my Nautilus friends. What's the plural for Nautilus? Would you say Nautiluses or Nautili? I've got 2 Nautiluses or 2 Nautili. I'm not sure. I don't know. Probably something I should have Googled. But we've got Nina and Nate, the Nautilus pair. Nina and Nate are going to say some statements, and I want you to decide who you agree with more, Nina or Nate. First statement. Nina says Fibonacci taught people how to calculate using Roman numerals. Nate said Fibonacci brought the Hindu-Arabic system of calculation, I should have added, to Europe from Africa. Who do you agree with, Nina or Nate? Second statement. Nina says the golden ratio is also known as the symbol phi, which you can see here. Nate says the golden ratio is also known as the symbol pi, which you can see here. Statement number 3. Nina said we can find the ratio between two numbers using division. Nate said we can find the ratio between two numbers using multiplication. I'm just going to quickly open a window because it's getting a bit incensey in here. Okay. Right, let's see what we've been saying. What have we been saying? So this is interesting because lots of people assume maths is black and white, like yes or no, right or wrong. I much prefer it when we can see it as some interesting ideas and sometimes spectrum of answers. So the first one, Nina said Fibonacci taught people how to calculate in Roman numerals. Nate said Fibonacci brought the Hindu-Arabic system to Europe from Africa. We know Nate is definitely correct because we've got evidence of that. It's like it's recorded that Fibonacci did do that. Fibonacci may well have taught people how to calculate in Roman numerals. I don't know. It's not necessarily that Nina's definitely wrong. We just don't know for sure whether she's right. The second one, we said Nina said the golden ratio is also known as this symbol phi. I'll turn you around and show you now. This symbol phi. Just here. Nate said that the golden ratio is also known as this symbol pi. In this case, Nina is definitely right. This is the golden ratio symbol. Pi is the ratio between the circumference of a circle and its diameter. Final one. Nina says we can find the ratio between two numbers using division. Nate said we can find the ratio of two numbers using multiplication. Well, the honest answer is we could do it both. We could use either or. One is just the inverse of the other. Today we used division. Today we were dividing in order to find that ratio. We could do it through a multiplication too. So technically they are both right. But today we went with Nina's version of using division. Right, that's all we're doing today. We're at the end of today's session. What I'm going to do is a little spiel, and then I'm going to go over to Facebook and read out any comments and anyone that says hi. These lessons, I put these out there for free. I got this model from Lara from Theatre of Science, absolute legend. So I put these out there for free. You can get the workbooks off my website, and then in return, many of you choose to pay me £5 or £6 a month for my time in planning the lessons, delivering the lessons, and all of that jazz. I say thank you to those people by sending you out. So what I'm sending you at the moment is this, my weather activity pack, which is all about weather and maths. There's activities to do. There's like a cloud spotter pull out, and there's lots of cool facts that lots of the older people wanted and fancied as well in there. And that comes with some cool freebies. It comes with a sticker, really cool sticker. It comes with some recycled sugar paper for a sun activity. And it comes with these recycled straws for a chaos activity, which is related to weather and maths. I'm not just talking about general chaos, but it could create that too. So if you sign up today, I'll send that out to you in the post this week as a thank you. Right, time to say hello to anyone that's managed to comment over on Facebook. Okay, let's have a look. There we go. Oh, hi, Teddy. I love all the eyes. Hi. Still in his PJs and singing into a welly boot. Well, why would you not be? That sounds absolute perfect morning to me, Teddy. I love it. I once made the mistake of teaching this lesson in my pajamas. I just shoved a jumper on and thought, oh, nobody will know. And then I had to stand up and you could clearly see I was in pajama bottoms. So, but I dream of being in pajama bottoms at this time of day, Teddy. I dream of it. Well done, you. And does the welly boot? Yeah, I need to try that out. I want to know if it makes your voice sound cool in some way. Hi, Connor. You helped me and Mum understand maths. We always thought we didn't get it. Connor, you do get it. You just need to get it in, like, yeah, your way. This is the problem I find with maths, is it's presented as though you have to do it in a specific way, and it's just not true. And I worked that out and then decided I'm going to tell everyone you don't have to get it in the prescribed way. There's lots of ways to get it. Thanks, Connor and your mum. Thanks so much for pointing that out. I appreciate that. Hi, Sophie, Emily, Katie and Hannah. Hi. Sophie wanted to show you her Santa doodle. Wow. Oh my gosh. You got 1.6 for your ratios. That's so cool. Sophie, you're super golden. That's awesome. Santa eating too many cookies. Oh, concerned dog. Oh, I thought at first that the dog was jealous and wanting some cookies. Shall I show everyone? Look at this. Isn't that cute? That is such a good drawing. Can you see that? Look, the concerned dog. Oh, I'm so worried about you. Dogs are so sweet like that, aren't they? I really think they genuinely worry about their humans. I think they're just... My dog does, but I probably give a reason to. Doing silly things. Morning from Chloe and Toby. Hi, Chloe and Toby. Chloe is 1.3 and Toby is 1.4. Mummy is closest to the golden ratio with 1.5. Now, that is interesting. That is interesting. Because now I'm wondering, as you grow, do you get closer to is it a bit like the Fibonacci sequence, where you have to keep going to get closer to the golden ratio? If I measured a baby, would it be like 1? And then it gets closer and closer as it gets older? So you're going to have to measure my kids and find out, see if there's some sort of pattern there. Wow, that is pretty cool. But yeah, nice to know your mum is golden. Hi, Aurelia. Our house is designed around Fibonacci, but not a spiral. But all the proportions are using numbers from the golden ratio in meters. Wow, that is amazing. What a house to live in. I would love to visit and see that in real life. That's so cool. There's a building, is it the Parthenon in Rome, where people thought it was all proportion about the golden ratio, but it's not. It's actually not. When they actually took the measurements and looked at it, where there should be straight lines, there was lots of curved lines, and they actually worked out it was even cleverer. The Romans had cut out all these blocks to make it look like this building was very, very straight from a distance, but actually up close it wasn't, because it was built on a slanted slope. Oh, it blew my mind. It was so cool. Aurelia, you also have a ballet show on Sunday. That is exciting. Does that mean you're like on a stage and people get to come and see you? I really hope so. That sounds so exciting. Good luck. Not that you need luck, but I hope it goes really well. What's the right words to use in this situation? Like smash it. But that always sounds a bit aggressive, doesn't it? I want like nice words, not like break something. Like break a leg. What a weird thing to say to someone just as they go on stage. Hello from Minecraft buff Archer and Merlin. Merlin likes fish and is also gold. Well, of course you're golden, Merlin. If you don't know, Merlin is a cat. And Merlin likes watching these lessons, don't you, Merlin? But yeah, we could have guessed Merlin was golden, couldn't we? More like a golden lion. You are. I bet you've got golden ratios too, Merlin. I bet you have special cat golden ratios. Okay, I'll just refresh one more time. Oh man, my voice is going. It's good job. Good job. This is my last live, really, isn't it? Oh, okay. Update on Toby, Chloe, and Mummy. Toby is the youngest, so potentially it is a bit Fibonacci sequencey, and you get more golden as you get older. That is cool. That is really cool. Okay, thank you so much for joining me, guys. We are going to be back here next week, doing another animal lesson that I have forgotten right now exactly what it is, but I'll put it on Facebook and other places today or tomorrow. But I am so looking forward to joining you again this time next week. You can also come on Tuesdays when I do the lesson on Facebook. You're welcome as many times as you like. I so appreciate you joining live or recorded. It is awesome. And I'm going to say bye for now and see you soon.